All right, good morning, everybody. How's everybody doing today? Awesome. So today we're going to talk about something that is very near and dear to my heart, and that's problem solving. And so this is my first time here at AI4, and I've been blown away by all of the new innovations, all of the new things that I've seen in the data science and data engineering worlds here as I've walked around and talked to people in the exhibition hall. And also want to give a special thanks to those that came by our booth earlier, or yesterday too. We definitely had some great engaging conversations, so thank you. And if you didn't get a chance to yesterday, definitely encourage you to come by today and strike up a conversation with us. So my background is kind of a mix of consulting and technology, but throughout all that, I like to consider myself as a problem solver first and foremost. And so seeing all these new technologies and techniques that we have at our disposal really gets me excited. So it gives me hope that we're going to be able to tackle ever more complex problems as we go forward. And so that really, my mind starts doing somersaults thinking about the possibilities here. But at the same time, I'm also a little bit frustrated. I'm a little bit frustrated because as consultants, we have the benefit of seeing across a lot of different client organizations. So across multiple industries, different groups within companies, different applications, and so forth. And without fail, we commonly see that a team has implemented an AI solution that, by most objective standards, is the quote-unquote best way to solve a problem. But somehow, that best way to solve a problem is passed over, unused, ignored, in favor of an approach that is far less analytically rigorous. And it all comes down to that AI approach failing in the most basic and most important objective metric, which is adoption. So if we're not adopting these things, they can't solve the problem at the end of the day. And the lack of adoption really stems from lack of trust. So lack of trust in a model, lack of understanding of what AI actually is and what it does, how it does it, and how it comes to a decision. So this morning we're going to talk about those issues and kind of our point of view on how we might tackle that going forward through a couple of use cases. But before we get to those use cases and illustrations, we're the math company, so we have to start with some numbers first. So I encourage audience participation in the numbers part here. So our first number, $136.6 billion. Anybody have any guesses as to what that represents? No, it's not the amount of tequila that was consumed on the strip last night. It's a little bit much. That is basically the estimated global value of the AI industry in 2022. Big number. Our next number is $1.81 trillion, so 13 times as much. That probably is accurate. They're a missed opportunity. But this is really what is projected to be the AI industry in 2030. So this is a 38% year-over-year growth, which is massive. So huge potential opportunity going forward here for all of us in this room. Next number, quite a bit smaller, and in my humble opinion, this should be much larger, but $21 billion. So $21 billion represents what we believe will be the explainable AI market by 2030. So only $21 billion out of that $1.81 trillion there. So it's something that hopefully by talking about it will make a change, and this number will prove out to be much on the low side. All right, next number, 83%. 83%. So here we're talking about the number of companies, or the percentage of companies that list or claim that AI is a top priority in their business plans. It's a tough one because, in a lot of cases, companies know that they really have to say now that AI is part of one of their top priorities because of just the importance in the industry. So it's a little bit hard to decipher this one, but needless to say, it's top of mind for most companies out there. And last number we're going to talk about, 38%. So this number is actually the one that shocked me the most. I was really surprised that it was so low, and it wasn't much higher. And 38% is the percentage of medical providers that actually use a computer as part of their diagnosis. And that doesn't mean use an EMR to record a patient visit or use a computer to look something up on their document system or something along those lines. It's actually used something to help their decision process when diagnosing a patient. Like I said, I expected this to be much higher. We know that quite a few clinical systems exist. We know that AI has permeated a lot of those clinical systems, but the adoption rate doesn't seem to be tremendously high at this point. So that's what we want to talk about today, explore that today with a couple of our use cases and to hopefully kind of understand the root of why that adoption may not be higher at this point. And so going into our first use case, so this is an outline of a simple business process for a prior authorization to be handled by an insurer. So the provider submits the prior authorization to the insurer. It goes through a process. The insurer decides, yes, it will be covered. No, it won't be covered. I'm sure most of you are familiar with the evil prior authorization and probably have quite a few horror stories to tell about how long it's taken or how it's kept you from getting the appropriate care. But this is a really good illustration of what we were talking about earlier. So starting on the left side in this process, our provider submits the information as requested to the insurer. We've inserted an ML algorithm into the process. So that ML algorithm its role is to take all those inputs from the provider and basically recommend a decision as to whether that prior authorization should be approved or denied. Now, in our case, unfortunately, our algorithm is a black box. So it's a black box. The people who are actually making the decision are responsible for the decisions, the medical directors. They don't understand it. They don't understand what goes in it. They don't understand what it does with the information. They don't understand how it actually recommends a decision at the end of the day. So their response is they don't trust it. They don't use it. They basically ignore it. They go about their jobs as normal, as though the ML algorithm wasn't there to begin with. So our process is the same length whether we have ML or not. We have a failure to adopt. Our poor patient, their experience has not been improved at all throughout the entire process. Our provider's experience has not been improved. Even our insurer their experience hasn't been improved throughout the process. So we can talk about why, but I just want to quickly jump into why it's important and why something like this, a seeming simple business process, is such a big deal. So it's estimated that prior authorizations add between $23 to $31 billion a year to the U.S. healthcare costs. So that's a massive number. $30 billion, that's a massive number. The average primary care physician in the United States spends upwards of $65,000 a year just dealing with insurance companies. It has nothing to do with treating their patients, just interacting with insurance companies, and most of that is because of prior authorizations. And on the patient side, 70% of patients will wait multiple days for their prior authorization to be adjudicated. So they don't know whether they're going to be covered or not. They don't know when they might get relief or not. So extraordinarily important, and at the end of the day, a denial of a prior authorization could mean denial of healthcare service to our patient. So it's critically important that we get this right. And I believe it's something that we have the capability to do it, and Explainable AI is actually something that can jump in here and help us out. So we take a look at the same process. The big difference here is we've inserted an Explainable AI component after the algorithm. So kind of runs the same way where the provider submits their information to the insurer, runs through the ML algorithm, but instead of going directly to the medical director with the decision and saying, hey, yeah, you should approve this, no, you should deny this, instead, it explains the features that were used to actually come to that decision. They can provide some background statistics, so like a histogram of how prior decisions were made based on similar situations in the past, and other descriptive stats that are important to medical directors and nurses who are making that decision. So instead of, in the next step, the medical director or the nurse just simply ignoring the model's recommendation and moving on with their lives, you have that they can focus their time and energy on those features. They can understand that decision, that recommendation better. They can they can actually trust it and rely upon it, and the timeline for turning around a prior authorization is drastically shortened. So at the end of the day, our patient waits less time. Our provider has a less nervous patient on their hand, so their experience improves. And the insurer has much less, the process is shortened. Medical directors can focus their attention specifically in the areas where they need to and not on routine prior authorization approvals. So it helps them out at the end too. Ultimately, the hope is that this will not just improve the experiences, but bring costs down overall. So simple change to the process here of introducing some explainability into the AI process, not even changing the algorithm itself, just introducing some explainability into the process can make an enormous difference. So we've talked here on healthcare, and we believe that healthcare is not just the only industry that's ripe for the assistance of explainable AI. Most, if not all other industries that we feel are in the same boat. We take a deeper look at healthcare. It's not just insurers. We have manufacturers of medical devices, pharma, healthcare providers themselves, all have opportunities here to implement some type of explainable AI to really improve the outcomes. And then quickly, if we look even deeper at insurers and payers, these are just some of the use cases that we've identified that we believe explainable AI will make a significant impact in terms of our ability to solve their problems at the end of the day. So I'm going to zoom out here a little bit and hand it over to my colleague, Sri, to talk a little bit more about the horizontal applications.
Thank you, Jeff. So just to make the transition very smooth, Jeff is a problem solver, and my team basically implements the solution. So I work as, so my expertise has been implementing most of the explainable AI here. If you really look at the horizontals, if you look at the different functions in the industry where you can basically focus on, let's say, implementing these solutions across the industry verticals that we basically saw. If you look at marketing analytics, if you look at revenue management, the numbers, the customer journey itself. So there are customer 360 platforms where we basically build enterprise solutions. If you just look into, let's say, just marketing analytics alone, some of the use cases that we have deep expertise on with respect to, let's say, retail media data, there will be some kind of an overlap. So if you look at customer journey, if you look at customer experience or customer analytics itself, you would need an overlap to, let's say, have more explainability with respect to the models that you're building. Let's say that you are actually building an enterprise 360 platform where you are aggregating multiple different data sources, creating those models, but we focus more on the data product itself with respect to the consumption. So speaking about consumption, I will probably deep dive into one particular example with respect to market mix. So you're running a lot of marketing campaigns. There's a lot of money being spent on advertisements. The tool basically will tell you as to where you need to actually put the money in, and how does the return basically would be generated. And the machine learning algorithm breaks it down. But when it comes to, let's say, building a product which has explainability to it, we build models where the end user, who may not be a technically savvy person, will have the what-if analysis. So he or she will be able to basically take the outputs of the model and look at it in a very holistic manner using explainability. So the users can review, they can take decisions based on it. So it's not just going to be that one particular model, which is very hard to understand. You start building trust with the data and everything around it, right? So Basically, just to end this off, with respect to explainability in AI, you talk about the trust that you build with your model. How does it come along in ensuring that whatever you're building is being consumed, and go forward from there. With respect to the various different approaches, it's all about having that one particular environment or one particular enterprise application that helps you solve this. That is something that we are building today. With that, Jeff, over to you.
Thank you. Just to close, wanted to just emphasize, if you take nothing else away from our session today, is just understanding the differences between the tools and techniques that we apply to a problem and actually problem solving. So kind of differentiating here, we're talking a lot about data science techniques, data engineering, and so forth. These are tools. They help us really accelerate our ability to solve ever more complex problems in the world, for sure, no doubt, and exciting advancements in the industry. But we need to make sure we take that step back and understand what it takes to solve the problem, the actual problem at hand, and not just the techniques that we apply to it. Like we mentioned earlier, the best model that's unused is really worthless at the end of the day. So adoption, so we feel that going forward, adoption is going to be a key component in solving problems utilizing AI and ML going forward. Thank you.